Hello everyone, Mr. Cummings here, and welcome to this brief catalog of forces. Let's start by just listing some of the types of forces we're going to be dealing with in this course, and we'll break it down between contact forces and non-contact. So the contact forces we'll have in this course are normal force, kinetic friction, static friction, tension force, spring force, drag force, and the buoyant force. Whereas non-contact forces we're going to be dealing with are weight force, or we can call it gravitational force. We can also call non-contact forces long-range forces. Let's start by taking a look at the weight force or the gravitational force. So it's a long-range pull force from objects that have mass. Any object that has mass should apply a weight force to any other object that has mass. So the agents that we typically deal with, the most common agent that we'll use is the planet Earth. But any agent or any object like moons, stars, black holes, galaxies, all of those have significant mass, so we could use those as agents as well if we're near those objects. The symbol we'll use, I'll commonly use F so with a subscript lowercase g, but we can also use F subscript W or F subscript capital G. The equation for the weight force on the surface of a planet is the mass of the object multiplied by lowercase g, which is its gravitational field in newtons per kilogram. The normal force is a force that arises when two surfaces interact. So it's a push force from a surface that is perpendicular away from the surface. The agent is a surface. The symbol is a F subscript n. And there is no set equation, so if we wanted to calculate the normal force, we would have to use Newton's second law, which we'll get some practice with later on in this course. Kinetic friction or sliding friction is a resistive force. So when an object is sliding across some surface, the surface can push in the opposite direction of that sliding motion, and that's going to give us kinetic friction. The symbol is F subscript Fk, or simply just F subscript F, and the equation is the kinetic friction force is equal to a term called the coefficient of kinetic friction multiplied by the normal force. And once again, our agents here are surfaces. So the last type of force that can arise from a surface is the static friction force. So unlike kinetic or sliding friction, static friction is the friction that keeps something from sliding. So something is at rest relative to another surface. A person or some other force tries to move the object. The static friction is going to keep it from sliding on that surface. The agent is still the surface. The symbol should be F subscript SF for static friction, or just simply F subscript F. And the equation is that the maximum static friction is equal to the coefficient of static friction multiplied by the normal force. Our next force is going to be a tension force. So tension forces are pull forces from ropes, strings, cables, anything that has some slack in it and can be pulled taut. And the direction of this force is always in line with the rope at the point of contact on the object. So again, our agents are ropes or strings or cables, and our symbol is F with a subscript T. There isn't a set equation for this either, meaning if we want to solve for it, we have to resort to Newton's second law and take a look at the sum of forces. So our next force is a spring force, and spring forces can apply pushes or pulls on an object depending on if they are compressed or stretched. So if we stretch a spring, the spring is going to try to pull back towards its natural length. If we compress a spring, it's going to try to push away back to its natural length. Our agents are springs and our symbols are F with a subscript S, and our equation is the magnitude of the spring force, symbolized with the absolute value sign, is equal to the K value, which is like a spring constant, times how far it's been stretched, which is that X, and we're taking the absolute value of that as well. So we have a drag force or air resistance force, which is a resistive force that results from moving through some medium, like a liquid or a gas, and we're colliding with those particles in that liquid or that gas. So the direction of this force is going to oppose the direction of motion through the medium, and our agents are airs or liquids, gases or liquids. Our symbol will be F drag or F air resistance. And our equation does exist, but it won't be used in this particular course. So our last force is the buoyant force, which is an upward force from an object either floating in a fluid or being submerged in a fluid or suspended in a fluid. So the agent here is a fluid, and the symbol is F subscript B. The equation is the density of the fluid that the object is resting in, multiplied by the volume of the fluid that's been displaced, multiplied by the gravitational field on the planet. So an equation or an example where we'd use buoyant force is if we had maybe a toy or an object that's placed in some beaker of water, and that object is floating on top of that beaker of water, or maybe even it's suspended inside that beaker of water. And that's it on this brief catalog of forces. Thanks for tuning in, and I'll see you next time.